These are the notes for LT2 and the electricity and magnetism unit. The task is to both model and calculate the electrical force between charged objects when using Coulomb's law. Back in Target 1, we learned that objects become charged due to an imbalance of positives and negatives. And the only way that can occur is when electrons are being transferred. Protons cannot be transferred because they are stuck in that nucleus, but electrons are free to move back and forth. So now, it's not enough just to say something's positive because it doesn't have enough electrons, or something's negative because it has too many. Now we actually need to calculate the attraction or the repulsion based on that. And that is what Coulomb does for us. Now, I highly suggest you pause me at this point. Make sure you have a calculator. You need to be able to run the scientific notation function. And make sure you have your formula sheet for Physical Science B. Obviously, there's a lot that's going to go on here. So, let's start this off. This half sheet, it's a half sheet of practice problems. It's on Moodle. Perhaps you have a hard copy, a paper copy of it. But Coulomb's law is really just a formula. All right, so when we write out Coulomb's law, it states that the electrical force on an object is equal to this capital K, I'll come back to what these stand for in a minute, multiplied by Q1, Q2, so obviously these two are multiplied by each other, and then the product of these is divided by the separation distance of the two charged objects, and that is squared. This K is a constant, and you know from math class, constants never change. The value of it is 9 times 10 to the 9th. And I know a lot of people aren't fans of scientific notation, but ultimately the reason we use it is if you wanted to write this out every time we needed it, that would be a 9 with 9 zeros. So what I'm trying to tell you is that's 9 billion. That makes electricity a pretty strong force, right? Which is why it's useful and also dangerous at the same time. Okay, it's because of this constant that helps to predict the electrical force. So we already said, we'll put a little key over here. K is the constant, never changes. Q1 and Q2. These are just charged objects. So from Target 1, we did the simulation with the sweater and the balloon. Perhaps Q1 was the sweater and Q2 was the balloon, or vice versa. If we rub a balloon on somebody's head, the balloon becomes charged up and your hair becomes charged up. So maybe those are the two different objects. And then as I mentioned before, D stands for the separation distance. So how far are those two objects apart? Now if we stop and think about some relationships here real quick, think about the charged objects first. All right, Q1 and Q2. Okay, Q1 and Q2. So charged object 1, charged object 2. We know if we have an increase size, we would have an increase electrical force. Okay, that should make some sense. If either one of these is more positive or more negative, you're going to get either a bigger attraction or a bigger repulsion. So when two things respond in the same way, we know that those are directly proportional. If we were looking for the relationship between separation distance and electrical force, well, if we look at the equation, that's an and, that doesn't look like it is. If we look at the equation, if this number gets bigger, if D gets bigger, you are now dividing by a much larger number, because that even gets squared, so it gets distorted even more. So if you divide by a much larger number, our answer is going to be smaller. We're going to get a weaker attraction or a weaker repulsion. So we would say that distance and electrical force, let's do it like this, an increased distance would cause electrical force to decrease. So when you see one go up and one go down, we know that that is an inverse relationship. All right, so Coulomb's law in words just says, all right, we've got this gravitational constant, and in order to figure out this electrical force, we multiply the two charged objects together, and we divide it by their separation distance squared. All right, that's what Coulomb's law does. Now, you have these practice problems, And notice I wrote one in for number 6 because on Moodle you're going to see these E's and you may wonder what is going on with that. We're going to put number 1 and number 6 in our notebook. All right, and then I will work through a couple more with you, and the answer key should be on Moodle for those. All right, if you decide to do the rest on your own. So this is where a calculator is essential, because I don't know that just watching me do this will be super helpful. So number 1, I'm going to write out all these into a list. All right, I'm just writing them off this practice sheet. So charge 1, charge 2, separation distance, K. So charge 1 is 5 times 10 to the 8th. That's what that little caret means. Charge 2, 6, whoops, that's negative 8. My fault, make sure you get a negative there. 6 times 10 to the negative 9th. The distance they give you is 3.5. Notice it's not squared yet, even though in the equation we need to do that. And K is 9 times 10 to the 9th. So there's the information we need. Now what I suggested to people that are in class, this is one of those times if I tell you to write some steps down on your formula sheet, it is not considered cheating. All right, so the steps that you would want to write down, I would just put them on your formula sheet instead of both places. You're welcome to put them in both places. But the process goes, for step 1, multiply Q1 and Q2. Okay, multiply Q1 and Q2. That's the first thing you need to do. So, again, put it in a little list on your formula sheet because everybody can use this forever and always. So we're going to go, and I'm always paranoid about order of operations. So I put everything in parentheses. I've been told it's not always necessary on this one, but it's better safe than sorry in my world. So 5 times 10, caret, is scientific notation, negative 8. Now close it up. We're going to multiply those Q1 multiplied by Q2. Q2 is 6 times 10 to the negative 9th. 6 times 10, caret, the negative down here, 9. Close it up, hit enter. There's an intermediate answer. There is no need to write it down. It is fine, just stored within your calculator. So, we have multiplied Q1 and Q2. Step 2 is to divide by the distance squared. Don't forget the squared. It is in the equation. That's a common question. Why, Lentz? Why do we why do we divide by distance squared? Because that's just the equation. So, we already have our answer stored in there. Divide by. Our distance is 3.5. So we're going to say 3.5 caret 2. We hit enter. All right. Big ugly number. Doesn't matter. We don't need to write that down either. Because our final step, this is always a 3-step process, is now to take whatever you have and multiply it by K. And K is 9 times 10 to the 9th. That will never change. Okay, so your final step, you take this, multiply it by, I always use parentheses, 9 times 10 caret 9. Close it up. All right. This is the answer. The 0 to the left of the decimal is irrelevant. 1, 2, 3, 4, 5, 6. There are 6 zeros. So decimal, 1, 2, 3, 4, 5, 6, 2, 2. When you take this target, you may get an answer like this, and the question may say to round to the nearest tenth. You're not going to round this, because 0 round to the nearest tenth is 0. That's not it. You only round if you want to convert this to scientific notation. So you're welcome to type it into Moodle exactly like this. If you want to convert it to scientific notation, it would be 2.2. You always put the decimal after the first whole number. And then you count how many spots does it take to get there. 1, 2, 3, 4, 5, 6, 7. So 2.2 times 10 to the negative 7th, that is that answer. So then it would make sense to round to the 10th. And since there's nothing else to the right here, it stays 2.2. Now, there will be times you have to type an answer like this into Moodle. Like that's just what you'll end up with. Your calculator will have this as an answer. Moodle does not accept the times 10. What replaces it is the letter E. Uppercase, lowercase, does not matter. But 2.2 E -7 is what you would type into Moodle. So to get this problem correct, you could go with this form, you could go with this form. You will get an error if you try to do that. Okay, so this or this. Most people choose that whenever possible because it's less work than converting. All right, so that's number 1. Number 2, I don't know, we're kind of out of room here. I'm not going to put it in the notebook. We're just going to refer to it here. All right, because there's nothing really to write down anyways for intermediate steps. But make sure on your formula sheet now you have all of those. Because again, everybody can use them all the time. So do that. All right, let's do the next one. Okay, let's do number 2. So here's my numbers. And step 1 says we multiply Q1 and Q2. I'll do the best. I'm going to have to hide stuff here and there. So 6 times 10 caret -9 multiplied by 4 times 10 caret -7. And just pause me. I do this a lot, so if I'm going too fast, pause me. Make sure you can get that answer. We divide it by the distance squared. That's step 2. The distance here is 100. So divided by 100 caret 2. Answer is 2.4 times 10 to the -19th. That's still an intermediate step. That's not our final answer. Our third step is to always multiply by k. So multiplied by 9 times 10 caret 9. And we get that. That is the correct answer. I would just type it into Moodle exactly as is, ignoring the one to the left. It doesn't matter. 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros and a 2. So you would type in a decimal. 1, 2, 3, 4, 5, 6, 7, 8, 2. Now again, if you need extra practice, go ahead, do 3, 4, 5. I want to do number 6 with you. All right. So what do these things mean? Uppercase, lowercase e, doesn't matter. This means 7 times 10 to the -9th. This one means 3, we see the e, times 10 to the -2. Obviously 125 means 125. 9 times 10 to the 9th. Okay. That's how you convert back and forth. So if this ended up being an answer, 7 times 10 to the -9th, you would type it into Moodle as 7e -9. All right, so let's just do this one real quick, just for one extra bit of practice. So it's 7 times 10 caret -9. Multiply it by 3 times 10 caret -2. We hit enter. We divide it by, second step, 125 squared. I hope that I hit divide. I didn't. All right. I got to catch up real quick. So 7 times 10 caret -9 multiplied by 3 times 10 caret -2. And don't do what I did. So we got to hit enter and then divide that by 125 caret 2. And we get 1.344 exponent -14. But then we got to do the third step, multiply by k. So multiplied by 9 times 10 caret 9. Answer is 0.000012096. And again, I would type it into Moodle exactly like that. All right, so that is LT2. The 3-step process is the most important skill from this target. All right, so as long as you've written it down, if you understand this, and then you understand this direct inverse relationship, it should be a good day. Good luck.